Right, we're continuing our lectures on 7.1. We're talking about the degree of a term. So when I take a look here at these monomials, or these terms coming from a larger polynomial, in order to find the degree, I'm looking at the sum of the exponents in the term. So in this one, I just have a single exponent, and so this is a second degreed term. Now we usually use ordinal numbers to describe the degree of a term. Ordinal means that it has the first or second or third, those terminologies with it. Our next one, we see the exponent has is a 3, and therefore this is going to be a third degree term. And finally, we're looking at a term that has multiple variables in it, and when we have multiple variables, we're going to add up all of these. So we're going to say this degree is 2 plus 2 plus 1, which means that we have a fifth degree term. And finally, we look at a lonely old number. A lonely old number, remember, we could write with x to a 0 power. So the degree of any constant is 0. So you do need to remember that. That's a special one, that the degree of a constant is 0. Don't forget. All right, the next thing that we're going to do is based upon the degree of a term, and that's the degree of a polynomial. When we want to know the degree of a polynomial, what we're going to do is we're going to look at the degree of each term, and then we're going to look at the highest one. So first of all, we're going to be able to tell where our terms are by finding addition slash subtraction. So I have a term here, here, and here in part A. And so I have a degree of 2 here for this first term, a degree 1 here for this term, and a constant, remember, has degree 0. So this is my largest one, and so this is a second degree polynomial. And that is all we need to answer. Now going on to our next one here, what we're looking at is we're looking at a first degree term here, a third degree term here, a second here, and a 0 here. So we have 0, 2, 3, and 1, and so our largest one is 3, so this is a third degree polynomial. Now this last one is no longer a polynomial because it has more variables in each expression than just the one. This one is an algebraic expression, but sometimes we have find the degree of algebraic expressions as well. So we'll revert back to what we learned in the last section, where example 4, where we add the exponents. So 1 plus 2 gives me 3, and 2 plus 3 gives me 5, and 2 there, and 0 there. And now I see that my highest one is the fifth, is a 5, so this is a fifth degree algebraic expression. And so we want to just bring along our information that we learned in finding the degree of a term to do those. Now the next thing that we're going to do is we're going to learn about ordering a polynomial. And in order to order a polynomial, what we want to be able to do is we just want to put them in descending degree, or in other words, our degrees go down from highest to lowest. So in example 7 here, I have a first degree, a third degree, a second degree, and a 0 degree. So I'm going to put my third degree term first. So my third degree is 4a cubed. And then I'm going to put my second degree term, which is negative 2a squared. And then I'm going to put my first degree term, which is a positive 3a. And then finally I'm going to put my constant, which is a 0 degree term 6. And that is an ordered polynomial. And that is again ordered because the degrees of the terms go down in degree, 3, 2, 1, and 0. Next is a polynomial function. A polynomial function is simply a function that produces values based upon a polynomial expression. So example 8, you see f of x is equal to 4x cubed minus 2x squared plus 3x minus 6. Well, that is nothing more than a polynomial function because you see the polynomial over here on the right, and when we put in values of x, it will produce dependent values based upon that polynomial, and that's what makes it a polynomial function. Next, we're going to talk about special polynomial functions and their pictures.